Okay, let's unpack this. Imagine you're staring down a mountain of data, maybe. Survey results, customer feedback, sales figures. You know there are golden insights buried in there, patterns that could change everything. But actually getting to them feels like, well, needing a pickaxe and years of training, especially if coding isn't really your thing.
That feeling is incredibly common.
Yeah.
Large data sets can be just overwhelming, and traditionally, getting meaningful answers required writing specific code, learning libraries, all that technical setup.
Right. It feels like there's this huge wall between you and the knowledge that's actually inside the data. But what if that wall just kind of evaporated? What if you could just ask the data questions, in plain English, and an AI would dig out the answers for you pretty much instantly?
And that's exactly the fascinating possibility our sources lay out today. We've been looking at material that focuses on a specific tool, Google Colab's data science agent.
So, our mission for this deep dive is clear. We want to dig into how this tool works, using real-world examples from the sources to show you how you can cut through all that complexity and unlock insights from structured data fast. And the key thing here, without writing a single line of code, think of it as a shortcut to being incredibly well-informed about a data set.
Absolutely. So where do we start? Well, the tool itself lives inside Google Colab. Our sources describe Colab as this fantastic free online platform. You just open your browser and you've basically got a fully configured environment ready for data science and machine learning tasks. Zero setup needed.
That zero setup part is critical, isn't it? Traditionally, just getting your tools installed and configured could take ages. Colab removes that barrier entirely. It puts powerful computing resources right at your fingertips, in the cloud.
Exactly. And inside Colab is the star of our show today, according to the sources, the data science agent. Its core purpose is described as extracting meaningful insights from data sets using AI and natural language. And the real game changer highlighted is this. You can perform complex data analysis without writing any code at all.
You just talk to it. You ask it questions about your data.
Precisely. You interact with it by prompting it in natural language. Now, to show us how this works, the sources use a perfect example data set.
Yes, they focus on the Stack Overflow Annual Developer Survey. Anyone in tech probably knows this survey. It's this huge collection of data. It reflects opinions, tools, demographics of developers all around the world. It's complex, it's real world, and it's exactly the kind of data set where, manually finding insights would be a massive task.
And crucially for using this agent, this data is available in a standard, accessible format like CSV, right?
Correct. CSV files are essentially structured tables, which the data science agent is built to understand and process. You can download the Stack Overflow survey data directly in this format.
Okay, so you've got your Stack Overflow CSV file, you're in Google Colab, the data science agent is ready. How does this process actually unfold? Walk us through the steps the source material explains.
Yeah, it's laid out very clearly. First, you simply upload your data. You just point the agent to your CSV file.
Got it. File loaded. Then what happens?
Then comes the key interaction. You ask a question, prompt. This is where you use natural language. So instead of figuring out how to write a Python query to, say, calculate average salary per country, you literally type, what is the average salary by country? Or maybe show me the top 5 countries by developer count.
So it translates your question into an actual data analysis task.
Exactly. And it doesn't just run blind. The source explains that after you ask your question, the AI first generates a plan. This plan outlines the step it intends to take to answer your question. You get to review this plan, see its proposed logic, and if it looks right, you click Execute Plan.
Okay, so it shows its work first. That seems helpful. What happens once you execute that plan?
Well, a few things happen behind the scenes, as described in the source. First, there's automated data cleaning. Data sets, especially real-world ones like surveys, they're often messy. They've got missing values, inconsistent formats, things that would typically require hours of manual preparation or complex code. The agent tries to handle this automatically.
Wait, it cleans the data for you? That's huge. That's often half the battle in traditional data analysis, isn't it?
It really is. It tackles common issues to get the data ready. Then there's the reasoning and analysis step. The AI interprets your question again, figures out which columns are relevant, like country and comp total for that average salary example, and builds the logical steps needed to perform the calculation or find the pattern you asked for.
So it understands the concepts in your question and maps them to the relevant parts of the data table.
Precisely. And finally, based on that reasoning, it performs the actual analysis through Python code execution. The AI automatically generates the necessary Python code to carry out its plan and runs it. The results are then presented right back to you, often with visualizations like charts or tables, if that makes sense for the answer.
And I don't even have to see the Python code if I don't know Python, or if I don't want to.
You don't have to write it, and you don't have to look at it if you don't want to. But the source does note that the agent shows you the Python code it generated, which is fantastic if you are learning, right? Because you can see exactly how the AI translated your plain English question into actual code. You could even copy and modify it yourself if you wanted to.
That's a great bridge, yeah, between the no-code user and someone who maybe wants to learn a bit more. The source also mentioned something about the agent potentially pulling in external data.
Yes, that's an interesting detail. The source says that sometimes, if the data needed to answer your question isn't available in your uploaded CSV, the agent might try to look for external data sources. However, and this is key, you can configure it to restrict it, to only analyze the data you provided. If you do that, and the answer isn't in your file, it'll simply tell you it can't find the necessary data in the dataset.
Okay, so it's powerful, but you can keep it focused just on your specific data. Got it. Now let's get to the really exciting part. With this capability, what kind of specific insights can you actually pull from data like the Stack Overflow survey using this method? The source gives a whole range of examples.
Yeah, this is where you really see the potential to understand the developer landscape just by asking questions. The source breaks down sample questions by categories.
Right, like understanding who these developers are, you can ask about demographics and background.
Exactly. You can easily query the distribution of respondents by their country, explore different age groups, or look at their highest level of education using the ed level field. Just by asking, you could quickly see, for instance, which countries had the most survey respondents, or maybe the general age profile of the developers who took the survey.
And beyond just who they are, you can probe their careers and professional lives, right?
Yes, the professional experience and roles category is really rich. You can ask about the most common dev type roles. Are they primarily back-end, front-end, full stack? You can analyze coding experience, separating overall years code from professional years code pro. You could quickly find out the average org size developers work in, or the prevalence of different employment types, like full-time versus freelance.
So you're building this picture of the who and the what they do in the developer world. And does it cover how they learn their skills?
It does. The Learning and Education section lets you ask about the primary ways developers learn code and the most used learn code online platforms. This could reveal shifts in how tech skills are acquired. Are online courses becoming more popular than traditional degrees among these respondents? You could just ask.
And of course, the tech itself. What tools and languages are dominant and what's sort of coming up on the horizon?
Definitely. A huge part of the survey, reflected in the source's examples, is technology and tools. You can query the most commonly used programming languages, language you've worked with. No surprise, you'd probably find Python and JavaScript high on that list. But you can also ask about the languages developers want to work with next, language want to work with, to spot emerging trends. You can do the same for web frameworks, web frame they've worked with, databases, database they've worked with, or other tools they want to explore, tool stack want to work with.
So just by asking a couple of questions, you could potentially see a gap, like maybe language X is widely used, but language Y is much more wanted, indicating a shift in interest or aspiration.
Precisely. You start seeing the current state and maybe the future aspirations laid out right there in the data. And the source then goes even deeper into a specific, very timely area, AI and machine learning tools used by developers.
Yes, this work gets really interesting. Connecting that big developer survey to the whole AI wave. It looks at, 3 dimensions of AI tool interaction?
Correct. The survey, and therefore the agent, lets you explore AI developer search tools based on actual usage, AI search dev hope worked with, future aspiration or desire, AI search dev want to work with, and community admiration, AI search dev admired.
Okay, so the basic question is just which AI tools have developers actually used?
Right, getting a list of the most common ones. But the sources really emphasize that the power is in asking more specific comparative questions. You could ask, how does the usage of a specific AI tool vary between, say, back-end and front-end developers using dev type? Or is tool usage different in the US versus India using country, or maybe in large versus small companies, org size? The agent helps you slice the data like this just from a question.
And on the wanted side, a search dev want to work with, you can see the wish list. What tools are developers hoping to use next?
Yes, exactly. Which AI tools are most desired for future work? And the sources highlight some really insightful questions here, like, What tools do developers want to use that they haven't used yet? Or does the desire to use certain AI tools increase or decrease with years of professional coding experience? Years Code Pro. You could look for patterns like that.
That's fascinating, seeing that gap between reality and aspiration and how maybe experience influences that. And then there's the third one, admiration. AI search dev admired. What does that capture?
This captures the perception, the respect factor. Which AI tools are most admired in the community? And what's fascinating here is when you start comparing these lists, the source suggests questions like, which tools are highly admired but have relatively low usage? That's a really key pattern. Why is something respected but maybe not widely adopted yet? Or does admiration for tool A differ significantly based on education level, ed level, or country? You can probe these nuances.
So you're getting beyond just simple counts and starting to understand the developer mindset around these important new tools.
Exactly. And the agent's ability to perform comparative insights across these three lists, used, wanted, admired, is really powerful. You can literally ask, which AI tools appear in all three lists? Finding the tools that have really achieved broad acceptance, desire, and respect. Or just look for general trends comparing the used versus the admired lists.
You could find tools that are maybe widely used but not particularly admired, or the other way around.
Precisely. And then the source points out the ability to perform cross-dimensional relationships. This is where you connect the AI tool insights to other aspects of the developer's profile or job. And what's really fascinating here, I think, is how you could start seeing potential links between the tools developers use or admire and their broader career satisfaction or even their compensation.
So wait, could you ask if using or admiring a certain AI tool correlates with higher job satisfaction, or maybe compensation, comp total?
Yes, those are exactly the kinds of sophisticated questions the source gives as examples. You could potentially see if developers who engage with certain AI tools report higher job satisfaction or perhaps different compensation levels. They even mention exploring the link with remote work preference, remote work. The AI agent handles the complex data operations needed to explore these correlations, all just from your natural language question.
Wow. That moves from simply listing data points to potentially uncovering factors related to job satisfaction or career success, all just by asking the right question in plain English. It's quite something.
It really unlocks a layer of analysis that previously required significant statistical knowledge or programming effort. The AI helps you probe these deeper relationships within the data.
And the source material makes it clear this isn't limited to just the massive Stack Overflow data, is it?
That's right. It explicitly states you can apply the same natural language, no-code analysis approach to other public datasets too. They list examples like the classic Titanic.csv dataset, iris.csv, which is common in machine learning tutorials, diabetes.csv, and housing.csv.
So you could use this exact same method to analyze survival patterns on the Titanic, explore characteristics of different flower species, look at health data trends, or investigate factors influencing housing prices.
Absolutely. As long as you have structured data in a compatible format like CSV, the data science agent in Colab lets you bring that data in and just start asking questions to uncover patterns and insights across all sorts of different fields.
So what does this all mean for you, our listener, if we circle back to the core message from the source's conclusion?
Well, it means that the barrier to entry for doing powerful data analysis has significantly dropped. The source reiterates that you do not need to be a coding expert anymore. Tools like Colab's data science agent genuinely put the ability to explore data, gain insights, and understand complex patterns into the hands of pretty much anyone who can ask a good question.
Kind of takes the heavy lifting out of the equation, doesn't it?
It does. It empowers students working on projects, enthusiasts who are curious about public data, analysts who maybe just need quick answers. It lets them bypass a lot of the traditional technical hurdles and go straight to the insights that actually matter.
It really is about making the ability to be data-informed much more accessible. Using these tools is a way to get deeply informed, find surprising facts, and understand what's truly happening inside a dataset just by asking.
Exactly. The focus shifts maybe from the mechanics of data manipulation to the critical thinking needed to formulate good questions and then interpret the results the AI gives you.
So given how accessible it is now to ask these complex questions of data, what kind of patterns might you discover hidden in datasets you encounter? How might this ability change how you learn about new fields or make decisions based on information you can now easily access?